Hi, this is Kevin. Welcome to my Beyond the Textbook lecture for uh, Zelle 3rd edition, Chapter 5. And while you're following along with the lecture, you may want to follow along with the slides. So there should be a copy of these in your weekly schedule. And you may want to follow along with the code. And the code that I'm going to be going through here is all in demonstrations to supplement Zelle 3E Chapter 5, which should also be linked in your weekly schedule. Okay? So let's get started. So, Chapter 5 in the Zelle book claims to be about sequence types, but the types are sequence-like, and we don't even have all the sequence types. So here's what we're going to talk about in this lecture: strings, lists, tuples, ranges. Those are all technically conforming Python sequence types, and files, which are sequence-like. So the commonly used Python sequence types include the string, which we use all the time, the list, the tuple, and the range. Although we don't often think of the range as a sequence, it's exactly what it is. Okay? And the question is, sequence of what? Okay? So if we have a string type, it's a sequence of individual characters. If we have a list, it's a sequence of items of any type. If we have a tuple, it's a sequence of items of any type, preferably immutable types. Okay, and why is that? Well, because tuples are immutable themselves, okay, and we usually use them to represent kind of historical facts, right? So we're not using them as some kind of a work area. So it doesn't make a lot of sense for us to have a tuple of mutable types, although they are supported. And a range, which often we don't think of as a sequence, it's just a sequence of ints. So the range function is a really succinct way of generating a sequence of ints, which we use a lot of times to control a for loop. Now, of these types, which of these are mutable and which are immutable? Well, they're all immutable except for the list. Okay, and that's really why the list really becomes our chief data structure for manipulating data within our programs. That's why it's so popular for that. Now, in Chapter 5, we show you a little bit of that, but we show you a lot more of that when we get to Chapter 11. Okay? In addition, the Python file is sequence-like. Okay, and it's included in the chapter because it really shows how these kinds of data structures have a synergy and can be used with each other. So I think it was a great decision. I just want to emphasize the fact that a file is not a Python sequence per se. Okay, it is an iterable though, and Python objects that are instances of an iterable type implement the for in construct. Okay. Now, we're going to go through a lot of the features of these commonly used Python sequence types. Uh, the range, the string, the list, and the tuple. Probably not exactly in that order. Okay. So what are their common features? Well, we've already talked about whether they're mutable or not. I wanted to emphasize that. So the only mutable one, the only one that you can change the contents of is the list. The range, the string, and the tuple are immutable. Okay. Now, what features do they have? Well, you can iterate with all of them, which is to say they all support for in. You can unpack all of them, and we'll show you that. Uh, you can refer to individual items with an index expression. We'll show you that. You can refer to a subsequence, one or more items within the sequence with a slice. We'll show you that. You can even do fancy slicing, which is more appropriately called extended slicing. I'll show you that. Uh, there's a delete operator, okay, that only works on the list. Again, you couldn't delete anything from a type that's not mutable. And all of these things, because they're Python classes, have methods, and we'll do some exploration of those. Okay? So let's talk about iteration. Strings, lists, tuples, ranges, and files are all Python iterables. All of these support the Python for in construct. And I put together a program in the demonstration project called 10 Demonstrate Iteration. And let's go look at that. Okay. So I'm going to open up this, give a little more room for the code. 10 Demonstrate Iteration. Okay, so this is it here. So what I do is I go through it and show you that you can iterate over a string. So I have a string example, a list example, a tuple example, a range example, and a file example. Okay, so let's do this. Let's put all the examples that we haven't gone over yet into a comment. Okay, so the first one is we can iterate over a string. It's not something we often do, but we can. So we created a string called vowels, which has the vowels A, E, I, O, and U. So we print the entire string, and then we use for in to iterate. We say for vowel and vowels, we print vowel. So we should print each item in turn. So let's go run that. And as you can see, we print out the heading string example, then the entire string A, E, I, O, U, and then each of the items in order. Okay, so something you might not do often, but you can do because string is an iterable, is you can access each of the characters in the string in turn. Okay, so let's move on and look at list. Okay, so in the list example, I've created a list called states that has Illinois, Wisconsin, and Iowa as members. And I print the entire list, and then I use the for in to print each state in turn. Print state in states. Okay, so let's run that. And as you will see, we print the heading, then you can see the list. That's what happens if you print a list in its entirety. And then in turn, I print Illinois, Wisconsin, Iowa in order. All right. Now let's look at tuples. Okay. Uh, very similar in terms of how they operate as to lists. Okay. You'll see that the syntax for creating a tuple is to separate the items with commas. And interesting, I have Oriole and Finch in double quotes. I don't know why I did that. I try to stick with single quotes when I can. I think they look a little more modern, but maybe not everybody agrees with me. Okay. Uh, and then I print the tuple as a single item, and then with a for in for bird and birds, I print each individual item. And let's go and run that. And you can see I got the heading, and then you can see the tuple. It does have the syntax that shows the parentheses and the items separated by commas. People will sometimes point out that it's the commas that make a tuple and not the parens around the outside, although that's not absolutely true in all contexts. So if you're trying to form a tuple, you do best to use the parens around the outside and the commas between the items. And then, of course, we visit each in turn, Dove, Oriole, Finch. Okay. Uh, Now the range. Let's look at range because we don't often think about range as a sequence. We think of it as a way to um, to visit a bunch of things in order. Okay, and it turns out that a range is a sequence of ints. So in the range example here, we print the heading. Uh, we call the range values. We do range 5, which is going to begin with 0 and go up to 4, but exclude 5. Okay, and then we print the range. It has a special um, formatting that's a little surprising. And then we visit all the individual ints. So we say for value in value print values. So let's go back and run that. And as you can see, uh, um, we have the heading. When you print a range, it prints in kind of a format like you defined it, although it does show, in this case, uh, we had said range 5, which is the same as 0, comma 5. So it prints it in kind of a generalized format. And then we see the values in the sequence is 0, 1, 2, 3, 4, which is not surprising because 5 is the stop value, as they call it. It's the first one that we don't want. So we want to begin with 0, and then we want to go all the way up and not include 5. Okay, so that's what that looks like. And then the very last one is the file. So let's get that out of the comment and look at that. So the file, this is pretty typical stuff that we learn in the content that's in Zelle chapter 5, where we're we create a variable that holds the path and the file name, typically called a file name as a kind of a shorthand. And then we call an open with the file name and the mode, in this case read, and the encoding UTF-8. Uh, if we print the file object, it looks kind of obscure. It's not very useful. We'll see that. And then we're going to print the lines in turn. So we iterate over the file for line and in file. Print line. And if we print line without stripping it, or are stripping it, which is stripping the right side, we're going to be printing something that ends with a new line, and we're going to get double spacing. So one way to get rid of the double spacing is this. We print line having called strip on it. And then, of course, we always want to close our files before we're done. So let's give that a run. Okay. So we get the header. When we print the file object, it gives us some useful information, but we don't see the context. And then we visit the lines, how, now, brown, cow. Okay, so as we said, all of these support iteration. Okay. Okay, now here's something that's a little surprising for beginners. Okay. Even lists which are mutable cannot be updated from within the kind of for-in construct that we just used. Okay, it's sort of a read-only construct in the way that we used it. Instead, lists are updated using index expressions. So in the program 12 demonstrate updating lists, I've got the code that shows you what works and doesn't work. Okay, so I've got two versions here. One that tries to do it using the basic for-in that we just saw. Okay, and unfortunately it doesn't work. So the heading here is trying and failing to update a list using a for-in. Okay, so we have the list states with the items Illinois, Wisconsin, and Iowa in kind of titled case. They have initial caps and the rest are low. Okay, and we're going to print states. Okay, before we do the for-in. So we're going to see what that looks like. And then we just use the classic for state in states. Okay, and then we refer to each of them by this index variable name, state. Okay, and we assign state with a call to upper. And you might think that when you're done and you print it out, we're going to have all caps, Illinois, Wisconsin, and Iowa, but unfortunately we don't. Okay, so when we're done, after the for-in, we still have mixed case. Okay, and this doesn't have to do with mutability or immutability. Remember that that Python lists are mutable. So if in fact this kind of a construct, a for-in used just this way, we're able to change the values of the items, it should have worked. Unfortunately, it does not. So this is a really handy way to visit all the items in a sequence, okay, but it's not a handy way to update them. Okay, Now let's go into the next part, and we're gonna learn about a couple of things at the same time. Okay. The way that we have to do this is that we have to use index expressions on the line where we try to update the list. So we have to refer to the state that we want to change as states index I within a loop that's going to control the value of I to visit all of them. Okay, and the same thing as we read it. Okay, so we're saying that uh, we're going to iterate over this range of indexes. Okay, and here's where you really come to realize that these range expressions are creating sequences. So yes, we are using a for in here, okay, but we're just using for in order to load up each of the index values in order. So if we say range of length of states, okay, uh, length of states is going to be 1, 2, 3. Okay, so we're going to get the sequence 0, 1, 2. So the first time through the loop, we're going to be using 0. So we're going to say states 0 gets assigned states 0 call upper. And then the second time it's going to be states 1 equals states 1 call upper. And then the third time it's going to be states 2 equals states 3 call upper. Okay, and that will really work. And here's where you really get in touch with the fact that ranges are really just tricky sequences that allow us um, to among other things. I mean, there are other uses of ranges, but this is probably the most typical one for us at this point in our careers. They allow us to have a counted loop. Okay. And when we run this, okay, we're going to see that before we run the loop, the three state names are going to be mixed case, and after it, they're going to be all caps. So let's give it a run. And here we go, all caps. So here's how you update the items in a list. You can't just visit them with the classic for in. It doesn't work. Admittedly, we're using a for in this way, but we're using a for in with a range, which gives us a sequence of these integer index values, which we're using in index expressions. It's only with these index expressions we can really update the items in a list. Maybe a little surprising, but that's the way it works. So that's iteration. Let's talk about unpacking. Okay, so all of the Python iterables support unpacking. It turns out even the files support unpacking. I'm not really sure what the use case is for that, but they do. Okay, so unpacking is implemented with an assignment statement. So we have individual variables. Now, a variable that's not pointing to some kind of a sequence is called a scalar. Okay, sequences are not scalars. So these are individual item types. So we have scalar 1, comma, scalar 2, dot, 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 gets assigned the value of the iterable. Okay, and what happens is that the items that are in the iterable are assigned to these variables in order. It's a good practice that improves code readability. It turns out that having a lot of code that uses those index values, they're not really strong on meaning, okay? And these kind of more typical variable names can have much more meaningful names. So let's look at this 15 demonstrate unpacking. Okay, so I'm going to go over to that project and open up 15 demonstrate unpacking. And I'm going to I'm going to show unpacking of all of these iterables, including files. Although uh, before I created this courseware, I had never unpacked a file. I was interested to discover that it worked. So here we're unpacking the characters in a string, and this isn't a common use case either, but we begin with the string vowels, A-E-I-O-U, and then we print it, and then we unpack it into first, second, third, fourth, fifth, much more meaningful names. And then we're going to print first equals the value of first, and fifth equals the value of fifth, just to show that we can do it. So let's do that. And then we go. So the first is A, that makes sense, and the fifth is U. Well, that works just fine. Okay, so let's do the same thing with a list. And unpacking a list is much more common. Okay, a classic case where we want to unpack a list is where we've done a split on a string, and we've split the string, say, into individual words. Okay, and we don't want to refer to them by their index numbers. We want to give each of them a name. Here it's first, second, third, which is not real different than the index numbers, but in real life it might be something like, oh, we'd split a string into first name and last name, and so the names on the left hand side would be like first name comma last name, right? So much more meaningful than strings index 0 and strings index 1. Okay, so we unpack them into first, second, and third, and then we show that the first has the first value. We're going to want that to be Illinois, and the third has the third. We're going to want that to be Iowa. So let's give that a run to get a little play button on screen here. And there we go. The first is Illinois and the third is Iowa, just what we were expecting. Okay, so if we unpack a tuple, okay, we're going to get the same behavior as when we unpack a list. Now, what would be the use case when we're unpacking a tuple? Well, we're going to learn when we get to chapter 6 that when we call a function or a method and it returns more than one value, okay, it appears to return more than one value when you look at the code. It really returns one thing. It returns a tuple. Okay, so if you wanted to get at the parts of it, you can either use index expressions, which again, it doesn't score high on the meaningful code scale, or we can unpack them and use much more meaningful names. And again, first, second, and third are not a lot more meaningful than 0, 1, and 2. Although 0, 1, and 2 are kind of the Python way of counting, so maybe first, second, and third are more meaningful. But typically when we're unpacking a tuple, that has been returned from a function, we have real meaningful names that we can unpack them into variables with those names. So we're going to unpack these and we're going to print the first, which should be Dove, and the third, which should be Finch. So let's go do that. And there we go. We got the first was Dove and the third was Finch. So pretty good. Okay, now the next thing that we're going to do is we're going to do this with a range. Okay. And would we have a lot of call for doing unpacking of a range? I've got to say that I haven't had a lot of call for this, but it does work. This is a feature that works with all iterables, and ranges are iterables. So we're going to create a range 5 and assign it to values. When we print this, it's going to tell us what range we have. And then we're going to unpack it into first, second, third, fourth, fifth. Okay. And we're going to think that the first is going to be 0, because again, in ranges we start counting with 0. And the fifth is going to be 4. So let's give that a look. So when we print the range, it prints kind of the code that you would use to create the range 0, 5. The first is 0 and the last is 4. So you might not get a lot of call for that, but it works. And last but not least, files. And as I said a little bit earlier, I was surprised that even though files are iterables, that they support unpacking, but apparently all iterables do. Well, let me say this. I found a tutorial somewhere that claimed this, and I haven't found any counter examples yet, so I think all iterables do. So what file are we going to do? Well, we have a file called words.txt, and I put that in the data subdirectory, and let's look. And it just says, how now brown cow. That's a sentence that we used to type when we would learn keyboarding and typing class years ago. I don't know if they still use that. And of course, the fifth line that appears here is just the new line at the end of line 4. Okay. So here's what we're going to do. We're going to open the file. Okay, we're going to print the file object. Again, that's not real useful, but we'll see some useful information. And then we're just going to unpack the file. Okay, so how now brown cow has 4 lines. And so we're going to unpack them into first, second, third, fourth. And again, these are not super meaningful, but we would have more meaningful names if we knew what was in the case. I guess we could have called them how, now, brown, and cow. And we're just going to say the third word is, and that should be brown. How, now, brown. And of course, it's always good to close the file. So let's look. Let's run this. And the third word is brown. Very nice. Okay, so I don't know how many use cases you're going to get for that, but it works. So all of these iterables that we're talking about in this chapter, they all support unpacking. And it's going to be good practice that we're going to follow in our class, that whenever we get an iterable, and we're going to process individual parts. If there's an opportunity to unpack and get access to the data with more meaningful names and using the index expression, then we're going to do that. So if it's appropriate to unpack, we're going to unpack. Okay, so that's unpacking. And they all support it. Let's talk about indexing. We've been using indexing, but why don't we dive into it a bit? Because I think it's explained fairly well in the Zelle chapter, but there are a couple of features of it that are not completely obvious. So, Python strings, lists, tuples, and ranges support indexing. Um, because they are proper Python sequences, okay? Files, even though they're iterables, are not sequences, so they don't support indexing. Indexing provides access to individual items in the sequence. Individual items can be referenced using index expressions. We've shown some of that already. The syntax that we use is we use the variable name, and then in the square brackets we put either an integer to represent the index number or some expression that's going to resolve to an integer. The first item in this sequence has index 0, and the nth item in the sequence has index n minus 1. So if uh, if the sequence were 5 long, the index numbers would be 0 through 4. The positive index values are numbered from left to right. Now, something that I don't think is emphasized quite so much in the Zelle chapter is that there are also negative index values that are numbered from right to left, and these really serve as synonyms for the positive ones. Okay, and we'll take a peek in a minute. Uh, and these synonyms are more clear in certain situations. Could you use the negative indexes all the time? Yeah, I think you could, and they could be very confusing. But in a couple of cases, resorting to the negative indexes is more convenient and easier to read. So let's look at how indexing works with strings. It works the same way with lists and tuples and ranges as well. But right now we're just going to look at strings. Okay. So here uh, we have a string with the name of a famous person in computing, Admiral Grace Hopper. And so her name is Grace space Hopper. Okay. And if we wanted to look at the index numbers of the characters, okay, uh, Grace is in index 0 through 4. The space is in index 5. Hopper is in index 6 through 11. And if we need an index to say that it's one higher than the last thing that we want to use, then of course we need to refer to the position that's beyond the last usable character. So even though the last usable character in Hopper, the R, is index 11, we do need to be able to refer to index 12. Okay? Now, here are the negative synonyms. Okay? They're numbered from the other end. So the very last usable character in the string has the index of -1, and then they increase as they go to the left. Okay? If you want to, uh, the negative values allow you to have expressions that, well, for slicing, which we haven't gotten to yet, that kind of go in reverse. And sometimes you need to say one higher than the end of the string if you're going from the back to the front. So you need a -13 to do that. So we're not going to go through all these, but we'll go through a few. Okay. So if we uh, if we put the string Grace Hopper into the variable person, okay, and at the REPL, at the command line or the shell, whatever you want to call it, we typed in the variable person, we would see Grace Hopper, that's the value. If we typed in person index 0, we'd get the capital G, and you just have to look up an index 0, you can see why. A person index 11 is going to give us the R, that's the N. If we said that we wanted to print person index 0, person index 6, we would get 0, G, and uh, 6, the capital H, we get the initials. Okay, so that's how you follow these along. Okay, now the very last thing that I show you here, oh, let me show you some of the negative ones. That's the second column. So if we say person negative 12, well, that's a synonym for the capital G. If we say person negative 1, that's a synonym for the lowercase r at the end. Okay. And we could print the initials that way. Now, one thing that I want to show you is if we try to assign a value to one of the characters, for instance, move a capital X to person index 0, because strings are immutable, it's going to blow up. So this is going to blow up if you try to do this kind of indexing to a string or to a tuple or to a range. It's not going to blow up if you try to do it to a list because lists are mutable. So let's move on. Okay. Let's look at some more indexing examples. Okay. So we're going to take a look at 20. It demonstrate indexing. All right. Let's open that up. All right. So we're going to, in this case, well, let's just take a look. So we're going to put all but the first into a comment. So with the string, we're going to do vowels index 1. I'm going to expect that to be E. Let's see that run. Run. That's an E. That's good. And now with the proper list, we're going to do states index 2. So 0, 1, 2. I'm going to expect to see Iowa. There's Iowa. That's good. Now we're down to a tuple. It should essentially work the same way because tuples and lists have a lot of the same capabilities except their mutability. So birds index 0, it's going to be dove. Let's see that work. Yep, dove. And a range, although we don't often think of ranges as something that we'd want to index. And some more kind of intermediate and advanced Python, you might want to do that. So values index 4 is going to be 0, 1, 2, 3. So we're going to expect to see 3. And we didn't get it. So the fifth value, oh, I'm sorry. Yes, I got it wrong. I adjusted the opposite way. So the fifth value in the range is index 4, 0, 1, 2, 3, 4. Okay. And those are going to be the same as the values. So index 4 is going to be equal to 4 because they both begin to count with 0. See? I fooled myself. We don't want to be doing a lot of that. Okay. Now the window doesn't want to move, but it moved. Okay. So that's indexing. Well, let's talk about slicing. And again, uh, they talk about slicing in in the Zelle book, but we're just going to maybe enhance that a bit. So all of the formal sequences, so that doesn't include files, support slicing. So slicing allows the extraction of subsequences. Now, a subsequence, the trivial case of a subsequence is one individual item. Uh, Usually it's two or more. So what's the syntax? Well, we have the variable name, and then in the square brackets, we put a stop integer, I'm sorry, a start integer, a colon, a stop integer. And we don't usually add extra spaces here. It's usually all crammed together. That's what the Python style guide likes us to do. I'm sorry. Here we are. Start is the index of the first item to be included. Stop is one higher than the index of the last item to be included. Omitting start causes a subsequence to start at the beginning of the sequence, so it's going to start at 0. Omitting stop causes the subsequence to continue until the end of the sequence. Okay, and so if you omit them both, you're going to get all of the items in the sequence. Now, would you get a lot of call for that? Maybe not, but it does work. Note that the positive and negative index values create synonyms. Okay, that's a little more helpful with slicing than it is with indexing. You can interchange positive and negative index values when convenient. Okay, so I would say that a good rule of thumb would be to say always use the positive ones except when it's more useful or expressive to use the negative ones. And again, they are synonyms for each other. Okay, so now we're back to the string Ada Lovelace. Okay. Oh, this isn't the same one we used before. Before we used Grace Hopper. So Ada Lovelace is another uh, uh, important woman in computing. Okay, and I think she was more appropriately Lady Ada Lovelace. Um, so again, if we wanted to look at the slice that includes Ada, it would be 0, comma 3. If we wanted to look at the slice that include Lovelace, it would be 4, comma 12. Okay. Um, and then if we wanted to do it using the negatives, well, then we would use them as synonyms. So down here in the examples, if we say, if we assign the string Ada Lovelace to person, and we get the slice person 0, comma 12, 0, colon 12, we'll get 0, if 12 is one higher, we're going to get the entire string. If we don't have a start and a stop, then we're going to get the entire string. Okay. If we say a person started 4, we don't provide the stop. We're going to start at 4 and go all the way to the end. in terms of using the negatives, okay, what if we said person start at 0, end at -1? Okay, so 0 is the capital A in Ada, -1 is the E, okay, but that's one higher, so we're going to just say love lack. So we get Ada love lack. Okay, if we say person 0 end at -4, again, -4 is one pass, so we're going to just get Ada love. Okay, and then again, if we try to assign a value to a slice of a string, that's not going to work because strings are immutable. Now, this kind of notation is going to work on a list. Okay, you can update a slice of a list, okay, because it's mutable, but you can't do it on a string because of these sequences that we can use this notation with, lists are the only thing that can be updated. They're the only things that are mutable. So more slicing examples, okay? So slicing works with not only strings, but lists and tuples and ranges, okay? So we've got another demonstration program, 25, slicing. And if you open that, you're going to see that slicing works with strings. We already know that, but it works with lists and tuples and ranges. So let's give it a quick look-see. Put everything but the string into a comment. So we're working with vowels, and we say vowels, and we just have the colon. We don't have the start or the stop. So we're going to expect to see A, E, I, O, U. And let's see what we get. Let's give that a run. Well, A, E, I, O, U. That makes sense. And let's see what this looks like when we do it to a list. Okay, so then we've got, we want, so states has the items Illinois, Wisconsin, Iowa. And we say we want to start at the beginning, and the first one that we don't want is 2. So 0, 1, 2, we don't want Iowa. So we're going to expect to say Illinois and Wisconsin. And let's look at this. We see Illinois and Wisconsin. That's good. Okay, now with the tuples, we're doing -2 and nothing. So -2, this is -1 is the last one. -2 is Oriole. So I'm going to expect to see Oriole Finch. So let's look at this. Oriole Finch. Now, again, you don't think of a slice of a range as something you'd want because it's probably more of an intermediate or advanced Python skill, but you might want it someday. So we're saying that we want values 1 and 2. Okay, 1 to 2. So we don't want 0. We want to begin with 1, so that'll be 1. We don't want 2, so we're going to expect to see 1. And let's see what we see. So a slice containing only the second value is range 1, 2. Oh, I'm sorry. So we want to start with 1, which is 1. It's going to be a pause because I think that should be wrong. It's going to be a slight pause. I got to get my head together. I'll be right back. Okay, I figured it out. This stumped me before. Now, here's what's uh, potentially confusing. When you slice a range, you get back a range expression. So, a slice containing only the second value in the range, uh, we're going to start with 1, and 2 is the first one that we don't want. So it's not a sequence 1 2. It's not like a list of 1 2. It's a range. It's this expresses uh, how to get this to go. So we ask for, if we go up here, we ask for a range 1 2, and we got a range 1 2. Now, if you convert that to a list, you'll see that that only includes the 1. So uh, here we print expressed as a list, a slice containing only the second value is 1. Okay, but when you express it as a range, it's 1 comma 2, stop before 2. Okay, so it's an apparent error when you're not thinking just very carefully, but it's not an error. I'm glad I've improved the example. Okay, so let's close that while we get the chance. Okay, and sorry, it doesn't want to move for a little while after we've changed it. So that's slicing illustrated. Okay, a little more details and including the negative values. Okay. Um, Good. Let's go on. So there is such a thing as extended slicing. I like to call it fancy slicing. Okay. Uh, it has a third value, right? Uh, so we have the variable name, the square brackets, a start, a stop, and a step. Okay, the step can be negative, so this is what allows us to have slices that go from the back to the front. Okay, so the start and the stop work the same as in regular slicing. Positive step values cause the extraction of the subsequence to happen from left to right. A step of 1 extracts the characters consecutively. A step of 2 extracts every other character from the string. A step of 3 extracts every third character from the string. Negative step values cause extraction from right to left. And I still have this expressed in terms of strings, but I just want to point out that this principle works with lists and tuples and ranges. Okay, so let's go on and look at another example with illustrated with strings. And again, we're working with the name Ada Lovelace. Okay, uh, and as you can see here, we assign the string Ada Lovelace to the variable person. So if we say that we want from 0 to 12 by step 1, we'll just get the whole string Ada Lovelace. If we say we want person no entry 1, we'll get the whole string. If we say that we want the person no entry 2, well, then we'll get the whole string but every other character. So that's of luck. If we change the step to 3, we'll get a capital A space lower VA. Okay. And of course, when we're processing strings, that doesn't always make sense. Uh, I mean, it's hard to think of the use case, right? But if we're processing a list of things, well, um, we could easily only want to take every second or every third one. We might be sampling, for instance. Okay. Um, what if we wanted to use negative step values? Okay. So again, the string is Ada Lovelace. If we say person no entry, -1, we'll get Ada Lovelace backwards. Okay. If we say person no entry, -2, we'll get um, uh, backwards every other character. If we say no entry, -3, we'll get backwards uh, every third character. And with strings, if we try to assign um, something to a slice of a string, well, it's going to blow up because strings are immutable. Uh, can we assign a value to a slice of a list? Yes, we can. We can't do it for a tuple. We can't do it for a range, but we can do it for a list. Okay. So let's look at more extended slicing examples. This is program 30 in the supplemental project. Okay, so let's look at 30. All right, and again, we go through strings and lists and all the way down to ranges. So we have the string AEIOU, and we want to do no entry, step of -1. Okay, and if we run that, we're going to say AEIOU backwards. That makes sense. So let's look at the list. So we have the list is Illinois, Wisconsin, Iowa, and we're saying that we want to go no entry. So we'll do the whole list, but we want to go by 2. So I'm going to expect Illinois and Iowa. Let's see how that goes. Yep, Illinois and Iowa. So this is going to work pretty much the same on the tuple, except we're using a step of -2. So I'm going to expect Finch, Dove. So let's see what we got. Finch, Dove. Very good. And then we're going to do it on a range. Okay. So we're going to take the whole range. So range 5 is 0 through 4. With a -1, we're going to expect that backwards. Okay. So let's look at that. And that says we want to start with 4. We want to go to -1. That's one past where we want to go. And we want to go by -1. And that's going to do it. Okay. Again, this isn't the sequence. This is the range expression that would generate this sequence. Okay. All right. Very good. If only this thing would move. There it goes. I still haven't found out why they don't move, why they pause. I've been web searching it now for about half a year. That's when it started happening. Okay, so let's talk about the del operator or the delete operator. Okay, now in the beginning of the lecture, I went through all the features that work for various of these constructs that we're talking about. So the delete operator is only going to work on a mutable type, and the only mutable type that we're talking about here are Python lists. Okay, so individual items may be deleted. One way to delete an item in a list is to use the del operator. Okay, uh, del statements may use index expressions. So you may say del, a variable name, and an index number. Del statements may also use slice expressions. So you might say del variable name and a start and a stop. So you can delete a whole slice. So let's look at 35 demonstrate delete in the supplemental project. Okay, so close up 30, open up 35. Okay, so here we are. We have Illinois, Wisconsin, Iowa. Okay, and we print that, and then we want to delete states index 1, 0, 1. We're going to delete Wisconsin. So I'm going to expect to see Illinois and Iowa. And let's give that a run. And we have Illinois and Iowa. Okay, pretty reliable. It's a mystery. My apologies for you having to watch this, but there it is. It unlocks. Okay, so that's the del operator. Only applies to lists. Methods. Okay, so Python strings, lists, and tuples and ranges have methods. Okay, and how could you know all of the methods available? Well, the best way is just to look in the documentation. Okay, as new releases of Python happen, they sometimes will add a method even to these classic Python classes that have been around for a long time. Okay, and if we wanted to look at the documentation, we pick up a new window, and let's just go to the Python documentation. It's easier for me to say, Python documentation. Let's see, str, that's the string class. And string common operations. I think we want built-in types. Okay. And then let's find string, str. And, there was an entry for string methods. And here they all are. We can capitalize, we can case fold, we can center, we can count, we can encode, we can do all of these things. We can do tests, which are only going to be useful once we get to chapter 7. We can ask, is it lower? Is it numeric? Is it printable? Is it upper? A couple things that were added recently, I think in version 3.9, yeah. Remove prefix and remove suffix. A common use case that we've had for a long time that we just want to remove some common characters from the beginning of a string or the end of a string. So these two The string class has been around for a billion years, and yet in Python 3.9, they just added remove prefix and remove suffix. Okay, and we're going to we're going to use these throughout the rest of the semester, right? So that's how you would find it. Uh, how would you do it for um, lists? Okay, well, let's look at lists. Uh, so we uh, here we've only documented the sort, but lists have many more uh, methods. So list tuple type. It's always in here somewhere. So let's go up to the top and let's look at list methods. List methods. Uh, well, let's look up here. Python list methods. Now I think we'll find a lot of tutorials. Okay, this is under data structures. Yep, here they are. They're under data structures. Append, extend, insert, remove, pop, clear. Okay, so sometimes finding them in the documentation is challenging. Here, there's a lot of tutorials. Geeks for Geeks is pretty good. Programize is not bad. W3 Schools is not bad. So some of these other kind of tutorial sites are good resources as well. So that's how we would find the methods. Okay. Now, some interesting methods of class. We can shift it to upper, to lower, to title case. Now, you always have to remember these all return a new string because strings are immutable. Okay, we can strip the white space at characters, which includes the new lines. We can split the string. We can find the lowest index of a substring. We can count the occurrences of a substring. Those are all kind of useful things to do. Okay, are these all the methods? No, we just saw many, many more. Some of the list class methods. Append, that's how you add things to the end of the list. Insert, insert an item in a given position. Pop will read the value and delete it so we can consume it. Remove will just remove it. Clear is going to clear the list. That would be perhaps we're using it again for the next batch of things. Now we're going to explore more of these when we get to chapter 11. More list class methods. We can ask for the index of a particular value that works the same as the string. We can ask for the count of a particular value. We can ask for it to be sorted. We can ask for it to be reversed. That'll be reversed in place. We can ask for a shallow copy of the list. Okay, so let's talk about tuples. The Zelle book in chapter 5 doesn't talk about tuples, which is why I assigned the chapter in the Severance book. So tuples are sequences of items like lists. Tuples may contain either homogeneous or heterogeneous items, so they don't have to be the same type. They can be, they often are. Tuples have a variable length, including empty. Okay. Now, Uh, that's to say that when you create one, you can create one of any length, including empty. Now, you can't change the length because tuples are immutable. The items in a tuple may themselves be either mutable or immutable. Okay? Using immutable types for the items in a tuple is considered a best practice because a lot of times we're using a tuple just to send the message. These are data facts that do not change. Now, you can't change the tuple itself. So, um, what a lot of people do is to use immutable types. Now, could you have a tuple of lists? Yes, there are. You can create a tuple of lists. Would it be better to create a tuple of tuples in that case to sort of emphasize these are, kind of historical, unchangeable facts? Yes, it would be better to create a tuple of tuples. Tuples are often used to hold related data facts that make up a record. Okay. Uh, Python functions that appear to return more than one values actually turn a tuple. So in chapter 6, when we get into functions, we'll see that functions that appear to return more than one value, they actually only return one thing. It's a tuple, and that contains all the values that were returned from the function. Some tuple class methods. Tuple has some of the methods that list has, but because it's not changeable, um, but two methods of tuple that are commonly used are count, where you can count how many items in a list match a particular value. That works like count and lists, and the same with index. It'll give you the index of the first one that matches. Okay, but a lot of things like sorting or removing or popping or appending. These are appropriate for lists because the lists are mutable, and they don't apply to tuples because tuples are immutable. A couple more features I'd like to talk about. Python escape sequences are all those character sequences that happen in a string that begin with a backslash, and I have a link here uh, to some documentation on this. So here are the kinds of things you can do. You can create with a backslash n, you can create a line feed, a new line. Slash new line is ignored, but I guess it's supported. If you want to have a backslash, you need two backslashes. If you want to insert a single quote or apostrophe, it's backslash apostrophe. Same for the double quote. And then there's a bunch of other things here. So this is a general capability of which you should be aware. Escape characters. And then while we were working on chapter 3, I introduced F strings as the current way to do string interpolations. So that's plunking values into a string when you format it for output. Okay, and included in that is any variable that we are printing, we can format it. And people often wonder what the rules are for that. And there's only one, even though there are a lot of approaches to formatting string, there's only one format specification mini language. And I've given you a link to that in the Python documentation. And it's a little, it's it's a little hard to read, and there's some better tutorials on this, but um, there's only one formatting meaning language. Okay? Okay. Uh, a couple of more features to talk about with files that are not emphasized in the Zelle book. One is that it's good practice when you're doing an open of a file to always include the keyword uh, parameter encoding equals UTF-8. Now, UTF-8 is the Unicode encoding that we use most frequently in the United States. Word has it that in some Asian countries they use other encodings more frequently because they're dealing with um, uh, ideographic characters. Uh, some of the things that I read and I've heard about said that they more frequently use UTF 16. If you're going to be a practitioner in Asia, you should consult with your coworkers and get the real answer to the encoding that they use over there all the time. Uh, if we don't include the encoding on an open, Python will try to guess how the file's encoded. It will usually do pretty well, but it doesn't look at the whole file to figure it out. So you can often get into problems by not telling Python how your file's encoded. Um, and one of the modes you can open a file with that's pretty popular and has a pretty good use case is not covered in the Zelle book. The Zelle book covers R for read and W for write, but there's an A for append, which causes records to be appended at the end of an existing file. And if you're accumulating a bunch of data and say processing a bunch of batches and you're say extracting them and you want to accumulate them all to the same place, you would use the A mode. Okay, so that's not in the Zelle book. And a regular feature, regular department of these beyond the textbook lectures is going to be this extra Python features department. And here's what I mean by extra Python features. There are certain parts of languages that computer scientists call syntactic sugar. So it's extra syntax that makes um, the language more appealing. Does it have to have that? Do you have to use that feature? No. Okay. So we have a link here to the Wikipedia article on syntactic sugar, which again is sort of a computer scientist pejorative term. Okay, and it says here, computer science, syntactic sugar is syntax within a programming language that is it's designed to make things easier to read or to express. It makes the language sweeter for human use. Things can be expressed more clearly, more concisely, or in an alternative style. Most of the ones I'll show you is in an alternative style that some may prefer. Okay? Now, these are things that are not included in the Zelle textbook or most beginner textbooks because if we begin to teach you 2 and 3 ways to do the same thing, for beginners it's confusing. Okay, so here we start. So there's a statement that's used with files that you'll see in examples. You know, if you're doing a lot of web searches and you're finding programs that deal with files, you'll find the Python with. So the with statement is a tool that creates a context manager. Context managers help to manage system resources like files. What other kind of system resources are there? Well, one common one is a database connection, right? And most typically, these kinds of resources have to be opened and they have to be closed. And if we don't close them, they don't get released. And in some programming environments, that can cause the system to degrade over time. So that's why when we've been working with files, I've been teaching you to close every file that you open. So if we're using the with statement with files, rather than having to close each open file explicitly, a program can use the with statement to close them implicitly. So how does it work? Well, we'll see that in a minute. So some intermediate and advanced Python programmers prefer this approach to having to manage the file closing themselves. Okay, and it manages some other things like recovery from errors and those kinds of things. In our class, you'll do fine to just open with an open and close with a close. If you decide to go ahead and explore the with, well then fine, that'll work fine. Do you have to use it? Definitely not. With is definitely syntactic sugar. Okay. So I've got two demonstrations. 40 is with a single file. That has a pretty easy way to code. And what if you had multiple files? Well, that's a little more complex, but not too bad. So we're going to take a look at some more demonstration programs, 40 and 45. Okay. All right, so let's close 35 and look at 40. Okay, so here we have a program that's going to read that words.txt file that we used before. Okay, and it's just going to print it out. Okay, but it's not going to close the file. So we begin the same way that we normally do. We have a string that holds the name of the data directory. We have a string that owns the file name. We use an F string to build the combination in file path and name. And then the open is actually coded inside of the with. Okay, so no matter what we do, if we do it the traditional way, as I've been showing you to do it, well, we still have to code an open, okay? The with can't imagine what it means to open the file. You have to tell it. So we say with open statement as in file, okay? And then we have a code block. So the code block is for line and in file, print line, strip, so that we're not printing double space. Note that there's no close statement for the file. There's no close at the end. The with statement causes the file to be closed when the with code block has finished. So what's in the with code block? The for loop. Okay. If we didn't want to use the with, well then, after the for loop, we would need a close for in file. So let's see this run. Okay. Run. Okay, so we run it and we do how now brown cow. And the file has been closed. You really can't, we're really not proving that, but it has. Okay, so this is not harder, okay? This isn't particularly hard, but closing the file wasn't particularly hard either. We just had to remember how to do it, okay? That's why the with, in my mind, really falls into this extra syntactic sugar category. But you'll find a lot of intermediate and advanced Python programmers are sticklers for always using a with. Somebody who taught them said you should always use the with. Okay, I'm not claiming that. Okay, so let's go to 45. How would this work with two files? Like, let's say that we were trying to copy words .text to another file called words copied .text. Well, then we would have an in file and an out file. So we'd set up the strings in the beginning for the name of the data directory and the name of the in file, words.txt, and the name of the output file, words copied .text. And then we would configure the names and file paths of the two files. So here's how you do multiple files. It'll work with 2, it'll work with 5, it would work with 20. Now 20 is a little extreme, right? So we say with, and then we code one open, a comma, another open, and then a colon, right? Now, I can't fit this all on one line, so I used a backslash line continuation character. If I left off the backslash, I would get a complaint, okay? If I put the backslash back in to tell Python, oh, I'm continuing the line, then it's fine. And then the code block within the with, it's pretty similar, except where we are printing it to the out file. So we have the keyword parameter file equal out file. Okay. And I've got a comment down here that says it's going to close them both when the with code block has finished, right? Okay. And then it's always good when you're going to print a file or you're going to do something that's not generally going to create output on the console, to print a message to the console so you can see on the console that it ran and you got some output. So something like the output file has been written to out file path and name is a great way to do that. So let's run that. And it says the output file has been written to, and then when the output file and name, and there it is, words copied .text. Okay, so this is classic syntactic sugar. Okay, you don't need the when. Okay, I think when we're using maybe more features of the when, like when we not only want it to close the file or the database connection, but we want it to do some recovery for us and those kinds of things. Uh, I said the when, I meant the with. Then the with gets more compelling. Okay, do we have any other of these extras or syntactic sugar features? Yes, we do. I'm going to show you something called string method chaining. So some Python classes allow their methods to be called in series. You know, call one method, then the next, then the next, then the next, using a special syntax called method chaining. Method chaining allows the output of one method call to be used as input to the next method call. So it sets up a pipeline of method calls. So, for instance, we could use a variable. Let's say this is a string. Okay. The string method of the classes we've learned about so far, the one that includes method chaining is the string class. So let's say the variable is pointing to a string. So we could call method 1, and then the result of that would be piped into method 2, and then the result of that would be piped into method 3, and then the result of that would be assigned to the variable result. So in addition to strings, which is the one common class which supports method chaining syntax. Many of the data science packages, including pandas, make extensive use of method chaining syntax. So even though we're not going to use it a lot in our course, or I'm not going to make you use it in our course, you certainly can. Um, when you move on to other data science courses, you're going to see method chaining, and we're going to use examples of how to do this with strings as training for how method chaining is going to work when we get to things like pandas. So I have yet another demonstration, the last of them, number 50. It demonstrates string method chaining. So let's take a look at this before we wrap up. Okay, so let's close all and open up our number 50 and get rid of that. Okay, so many of you already know that the name Python was inspired by Monty Python's Flying Circus, the comedy troupe. Okay, so we have a string. The original content is Monty Python's Flying Circus, and you can see that we use an escape sequence to insert a single quote or apostrophe in a string delimited by single quotes or apostrophe. And then we're going to print the content. So we're going to expect that to say Monty Python's Flying Circus. And then we're going to show you how you would manipulate the string using calls to the string methods done in turns and the results put into intermediate variables. So we begin with a content we call lower, and we store the result in a variable called lower. Then we call upper on lower, and we store the result in a variable called upper. Then we call a title on upper, and we store the result in a variable called title. And then we print it, and we're going to see again the same thing, Monty Python's Flying Circus, because that's already in title case. And then we're going to do it again using method chaining syntax. Okay, so you could do it like this. If you wanted to assign the results to result, you could take a content and call lower and chain that to upper with a dot. That's how the syntax works. It says like take a content, call lower, then to take the result and call upper, then take the result and call title. And then of course the result of that all goes to result. And then we print the result, which again is going to be in title case, capital N, capital P, capital F, capital C. And let's give this a run. And we'll see here the original content in title case. The one that used intermediate variables is in title case. And then the one that used method chaining syntax is in title case as well. Now, you might ask yourself, is the one that uses intermediate variables more efficient than the one that uses the method chaining? And I would say maybe a tiny bit. Okay, once we interpret this Python and we turn it into Python bytecode. Every time we store a result in a variable, we get probably one line of Python bytecode, and it might be true. It's not necessarily true. It might be true that that might make the code of this one that uses intermediate variables just a little bit longer than the code that uses method chaining. But in terms of Python bytecode, it might be the difference of, um, you know, 53 instructions rather than 50. Okay. And again, if you want to see the difference in the performance of your code, I don't know which one is faster. It might be that the intermediate one's faster. I doubt it though. But you'd have to run it a million times to see the difference. And so the question isn't the efficiency of this, it's that what's more expressive. And it turns out that for us here, these are both pretty expressive. Okay. Um, but in these, if we go back to, sorry, you just have to wait for this to unlock again. There it is, and unlock. If we go to data science packages like pandas, they have a lot of method calls that do things like filtering and things like that. And having this idea of creating a pipeline that one operation creates the output for the next operation, creates the outputs for the next operation. I think it probably is true that the method chaining syntax that we see here is pretty darn expressive for that. So I know why they favor that. Now, for use in our course, you certainly don't have to use it. You can try it if you want to. Every time I drop something on the screen, it freezes there, no matter what I do. I'm so sorry about that, folks. Maybe one more time. All right, let's click on the other thing to bring it to the front. Okay. Um, While I was creating this, I used two resources that you may want to consult. One, of course, is um, the Zelle book, which you already have. But the other one is this Python in a Nutshell, which is one of the O'Reilly books, which is a really good Python reference that I use not every day, but from time to time, especially when I'm working on courseware. So I wanted to recommend it to you. And so that's it for chapter 5, Beyond the Textbook. I'm going to say bye until next time. Bye bye.